Welcome D-Lab everybody. Today I've got kind of a unique project. It is a Pignose amp. The model G40V came to the shop because it was dead. And I thought, well, maybe it popped a fuse, right? Or maybe a bad connection, or the power switch could be bad. But nope, it was the worst possible thing. The power transformer primary winding is open. The funny thing is, it has a rear fuse holder, and then there is a inline fuse, both going to the primary of the transformer. Neither of those blew, but for some reason the primary of that power transformer is open. But timing was good because the owner said this thing was too loud anyway. It runs a pair of 6L6s. So what he wants me to do is reduce it to a 6V6 amp because he is a Harp player. So we're going to pull out this crazy power transformer and put in this old stock Stancor that I have and replace the output tubes with 6V6s. Should be a cool video. Here we go. Now here's the bottom side where the main power transformer rests. So the white and black leads are your primary, and then you see our secondaries. There's actually only 4 wires. So the blue is the 6 volts for the filaments. The 2 reds are the high voltage, so they have full wave rectification going on this board. When I put in my new transformer, it actually has a center tap, so we won't be using this diode configuration, but that's an easy change. I've got the original transformer removed, and as I stated, the primary is wide open. Nothing, nobody's home. But now my new transformer, the holes are not going to line up on this base, so I'm going to have to re-drill and get that guy mounted up. Then we're going to wire it in and do a temporary power up just to make sure that everything lights up. There's that nice Stancor transformer mounted up on the chassis. Looks original. I removed the 6L6s and we have installed a pair of 6V6s. Biasing on the amp will change because he wants lower output for Harp operation. Bottom side, I installed a terminal board for the new power transformer to land to. This is our filament feed. High voltage now is these 2 red wires that go over, and we have a center tap full wave rectification. So 2 of the diodes have been removed. Okay, let's test it out and see if we can get some sound through this thing. Alright, we're just going to do a quick test using an audio generator as a source. I'm monitoring on my test speaker. I just want to see if we're getting some audio. Here she comes. Yep, she's a-working. Okay, so at this point, since we've put in 6V6s, I need to check the biasing. I don't know how they're running right now. I know they're amplifying, but I'm going to cut over to the schematic and I'll show you a couple changes I'm going to make to the Pignose amp. So here's a free online schematic for the Pignose G40V. Original configuration, it had 6L6 output tubes. We have now changed that to 6V6s. The high voltage is pretty close to what it was originally with the Stancor transformer, but it's slightly lower, which is good for the 6V6s that I'm going to install. So I need to know what the bias is through the new output tubes. And if you look at their pin 8, they simply grounded it. So what I'm going to do is add a 1 ohm resistor in line with the 2 pin 8s so I can monitor the current through the 6V6s. Then we need to make sure that the negative bias is variable. In this case, it was a fixed negative bias at negative 43 volts. I'm going to add a pot so I can dial in the bias for the 6V6s. Alright, just for reference, I have the 1 ohm resistor installed now going to the cathodes of the 6V6s, and I'm monitoring the voltage drop across those cathodes, and look, we don't even have 1 millivolt, meaning they're not pulling much current. So I'm guessing the negative 43 volts negative bias they show here is much higher. Look at there, we've got almost negative 72 volts. That's because of the different grid draw of the 6V6s. So yep, it's time to add the variable bias control. Okay, I've installed the variable negative bias. I simply removed R2, which is a 56K, and installed a 50K pot on the chassis, which is located right there. So I'm monitoring across that 1 ohm resistor so we can see the current through the 6V6s. Let's see if we can dial up some milliamps now. I just applied power to the amp. Should see some milliamps. There she comes. Now, remember before I could only get like 1 milliamp of current. Now we have adjustable current. So for this setup we're going to put them at 20 milliamps a piece. We'll hook up the audio generator and see if we get a little bit more output now. Alright, audio generator's hooked up. Sure sounds a lot nicer, a lot fuller, because the 6V6s are actually doing something. So there is our idle current. So if you divide that by half, each tube is getting approximately 21 milliamps. So I noticed now that the amp is up and pulling proper current, we do have some microphonic tubes. So listen to this. Hear that? Appears as though the first preamp tube is extremely sensitive. Oh yeah, can't have that, so we're gonna have to check the tubes. Alright, successful repair and update of the Pignose G40V to run 6V6 output tubes. It's not the prettiest looking thing in the world, but it sounds great. I think the owners can be very happy.